Example 3 is giving us that our curves are y equals negative x cubed plus 3 and y equals 0, and that we're looking between negative 2 and positive 1. So I know that this is a cube function, and I know that my cube functions typically look something like this, but this is going to be reflected because of the negative, so I know that it's going to be flipped, and I know that it's going to be vertically shifted up 3 units. So let's go ahead and graph this. So again, I know that I'm going to be shifted up 3 units, 1, 2, 3. And then I go up 1 unit and 1 to the left, down 1 unit and 1 to the right. And then if I plug in a negative 2 in place of my x, the negative of negative 2 cubed plus 3 would actually be 11. So 11, let's call that guy 11. And we'll go ahead and just graph this function. And that's y equals negative x cubed plus 3. Y equals 0 is our x-axis, so that's this guy right here. And again, we're looking at between negative 2 and positive 1. So we want this area right here. Well, that area is equal to the integral from negative 2 to 1. Notice the blue curve is always on top, so it's going to be negative x cubed plus 3 minus, and on bottom is always going to be 0 dx. So let's clean this up before we integrate. So we're looking at the integral from negative 2 to 1, and that's just going to be negative x cubed plus 3 dx. So the negative is a constant multiplier. We know it multiplies along, and here n is equal to 3. So my area is going to equal negative 1 over 4 x to the 4th plus my constant here is equal to 3, so 3x, evaluated from negative 2 to 1. Plug in my upper limit of integration. So a is equal to negative 1/4 times 1 to the 4th plus 3 times 1. And that gets subtracted from, plug in your lower limit of integration, negative 1/4 times negative 2 to the 4th plus 3 times negative 2. So let's plug it into a calculator. So we're going to do negative 1/4 times 1 to the 4th plus 3 times 1. All that subtracted from negative 1/4 times negative 2 to the 4th plus 3 times negative 2. Hit enter and I get 12.75. So my area is equal to 12.75, or as a fraction, we're looking at 51/4. All right, last one, number 4. We're looking for the area that's trapped between y equals negative x squared minus 2x, y equals 0, and between negative 2 and positive 1. So I look here, and I know that this is a quadratic, and I know it's a quadratic that opens down. So since it's not in standard form, the easiest way to graph this is just to figure out what's happening at negative 2 and what's happening at positive 1. So if I plug in a negative 2 in place of my x here, I know that I would get the negative of negative 2 squared minus 2 times negative 2. So when x is negative 2, y is 0. And then let's figure out what happens when x is 1. So it's the negative of 1 squared minus 2 times 1. And I get negative 3. So that's enough to kind of help me when I'm graphing this. So if I graph this, I know it's a parabola. I know it opens down. I know that it crosses here at negative 2. And at 1 it's at negative 3. So I need to make it look like a parabola. Then y equals 0, we know is the x-axis. So here is my x-axis. And I want to find the area from -2 to +1, so I'm actually looking for this yellow area. Now notice the same curve isn't always on top. So I have to find first my point of intersection. So I have to figure out where these two graphs intersect. So my point of intersection is found by setting -x² minus 2x equal to 0. So -x² minus 2x equal to 0, and solving for x. Well, I notice that I can factor out a -x from each one of these, and I'm left with a +x plus 2. Set both of these equal to 0, and I get here that x is equal to 0, and here that x is equal to -2. Well, I already knew that I intersected at -2, but that means that this point of intersection here is 0. Therefore, if I want to find the area, that yellow area there, I know that my area is going to equal the integral from -2 to 0. There, the curve that's on top is the red curve, which is -x² minus 2x, and that gets subtracted from the blue curve, which is 0 dx. And I need to add that to the integral from 0 to +1. There, the curve that's on top is the blue curve, which is 0, minus the red curve, which is that -x² minus 2x dx. So all we need to do is clean this up, and then we can integrate and evaluate. So a is equal to the integral from -2 to 0. This just becomes -x² minus 2x dx, plus the integral from 0 to 1, and here the 0 goes away, but if I distribute that negative, this becomes +x² plus 2x dx. So let's go ahead and integrate all of this. So if I integrate here, I get negative. Remember, your n is equal to 2. 1/3 x cubed minus, remember 2 is the constant multiple and multiplies along, and your n here is equal to 1. So minus 2 times 1/2 x squared, and this gets evaluated from -2 to 0. Plus, let's integrate the other one, and my other one integrates as, well, here my n is equal to 2, so you're looking at 1/3 x cubed plus, remember 2 is a constant multiple, multiplies along, our n here is equal to 1, so times 1/2 x squared, all of this evaluated from 0 to 1. So if I clean it up, I know here my 2's will cancel, and here my 2's will cancel. So plugging in my upper limit of integration here, I get my area is going to equal -1/3 times 0 cubed minus, remember those 2's canceled and it's just 0 squared. And that gets subtracted from my lower limit of integration, which is -1/3 times -2 cubed minus -2 squared. And that gets added to, okay, well, I need to evaluate this upper and lower limits of integration. So my upper limit of integration would be 1/3 times 1 cubed plus, remember these 2's canceled, so it's just 1 squared, minus my lower limit of integration, which is 0, so it would be 1/3 times 0 cubed plus 0 squared. So we can put all of this into a calculator. There's just one thing that I'm going to do real quick just to make the calculator computation a little easier. Please notice that here, this is -1/3 times 0 minus 0. Well, anything times 0 is 0, and 0 minus 0 is 0. So this term basically is just 0. Same thing for the last term. I have 1/3 times 0 cubed plus 0 squared. Well, anything times 0 is 0, and 0 plus 0 is 0. So those terms don't need to be put into a calculator because they're just going to be 0. So in my calculator, I'm going to place the negative of -1/3 times negative 2 to the third minus negative 2 squared. And then I need to add that to this one, which is my 1/3 times 1 to the third plus 1 squared, which is, in the end, 2 2/3. So if you make this into a fraction, you end up with 8/3. So the area bounded by the curves of this negative x squared minus 2x, y equals 0, from negative 2 to 1. Remember, we had to switch here at 0. We had to have two different area calculations because the top curve wasn't always the same. Well, that area ends up being 8/3. That's it for section 6.1.